This is lesson 2.8, finding the greatest common factor. The objective of this lesson is that you can find the common monomial factor in a polynomial. We're also going to find the other factor after we divide by that greatest common factor, so that it's not stated on our objectives. You need to know what a monomial is, a number or variable or product with a non-fractional exponent, and a polynomial is the sum or difference of monomials. The greatest common factor is the greatest term that can be divided into and is a factor of each term in the polynomial. When you were working with fractions, possibly in Math B, you talked about the greatest common factor of two numbers. For example, if you had 18 and 12, and you were asked what's the greatest common factor, or GCF, you wanted to know what's the biggest number that divided into each of those two numbers. Well, all numbers have factors. Factors are two numbers that you multiply together to equal your product. For example, what are some numbers that multiply together to equal 18? How about 1 and 18, 2 and 9, and 3 and 6? When you're finding your factors, if you write them down in pairs, you can see what all the factors are. Because there's no numbers between 3 and 6, I know that I'm done. The factors of 12 are 1 and 12, 2 and 6, and 3 and 4. There's no numbers between 3 and 4, so there, I know I'm done. So each one of those pairs are called factors. The greatest common factor is the biggest number in both sets. So what's the biggest number in both sets? Well, it's the 6. That's if you were just trying to find the greatest common factor of two numbers. But now we're going to be looking for the greatest common factor in two terms of a polynomial, or finding that monomial that divides into both terms of a polynomial. So let's take a look at focus question number 1. We've done the hard part for you, or I've done the first step for you, and that's finding the greatest common factor of the coefficient. So we're going to do this in 3 steps. The first step is to find the greatest common factor of the coefficients. Well, our coefficients in focus question 1 are 18 and 12. I just showed you a second ago that the greatest common factor was 6. That's the biggest number that goes into both 18 and 12. To find the greatest common factors of variables, you want to look at each term and what variables are located in both terms. Well, both terms contain a p and both terms contain a b. The exponents, though, or for the greatest common factor, the exponent is determined by the smallest exponent. For example, on p's, the exponents are 5 and 3, which is smaller? The 3. For the b's, the smaller exponent is the 2. So to find the greatest common factor monomial, you will combine all 3 of these items: the greatest common coefficient and the greatest common variables, p to the second. So that is our greatest common factor, 6p to the third, b to the second. I'm going to write this down here below here, 6p to the third, b to the second. That is our greatest common factor. The other factor, or the other term that you would multiply, or as in terms or polynomial, that you would have to multiply to the greatest common factor, is determined by dividing each term by the greatest common factor. So I'm going to write a set of parentheses here. And what you will do is you'll divide each term above by the greatest common factor, or 6p to the third, b to the second. 6p to the third, b to the second. Well, look at your first term. 18 over 6 reduces to 3. So you're dividing. P to the 5th over P to the, that's a 3, is P to the 2nd. B to the 2nd over B to the 2nd, just cancel out, it's just like 1. Plus, now divide the second term. 12 over 6 reduces to just 2. P to the 3rd over P to the 3rd, those cancel out. B to the 7th over B to the 2nd is B to the 5th. Okay. So we've done actually the first step in what's called factoring, is finding the greatest common factor of a polynomial, and we found its factor pair by dividing. Let's try another one. The first step is to find the greatest common factor of the coefficients. We have 24 and 8. Now, if you don't want to write down all the factor pairs of 24 and 8, a shortcut is to ask yourself, does the smaller coefficient divide evenly into the larger one? If so, then that means that is the greatest common factor. Well, can 24 be divided by 8? Yes, it does. So the greatest common factor of the coefficients is 8. The greatest common factor for the variables, well, both terms have an x, both terms have a y. Look for your smallest exponents, though. The smallest exponent on x is 2. The smallest exponent on y is 1. We don't need to write the 1 there, but I'm just writing it so you remember. Put it together to find the greatest common factor, 8x squared y. So our greatest common factor is 8x squared y. To find the other factor, you divide the polynomial by the greatest common factor. 8x squared y divided by 8x squared y. Alright, look at your first term. 24 over 8 reduces to 3. X to the third over x to the second is just x. Remember, you just subtract your exponents. Y to the first over the y to the first is 0, so the y's cancel out. My line didn't go. Minus 8 over 8 is just 1. X squared over x squared is x to the 0, so you don't write anything. Y to the second over y to the first is just y to the first, or just y. You could have wrote 3x minus y is the same thing. So there's the greatest common factor and its factor pair. If you wanted to check your work to see if you have the right answer or factor pair, you should be able to multiply or distribute the greatest common factor inside the parentheses and get your original problem. 8xy times 3x is equal to 24x to the third y, and 8x squared y times negative y is equal to negative x squared y to the second. So that's a way you can check yourself. Let's try another one. Alright, first step is find the greatest common factor of the coefficients. We have 12 and 36. Again, let's use our shortcut. Does 12 go into 36? It does. So our greatest common factor is 12. Our variables that are common in both terms are y and z. There is a y and a z in both of them. But what's the most y's and the most z's that you can divide both of them by? Well, you look for the smallest exponent. Our smallest amount of y's is y to the second, and our smallest amount of z's is z to the 8th. That means our greatest common factor is 12, y to the second, z to the 8th. If you divide both terms by the greatest common factor, so we have 12, y to the second, z to the 8th. If if we divide both terms by the greatest common factor, we'll find our other factor pair. So 12 over 12 reduces to just 1. Y to the third power over y to the second is just y. And z to the 8th over z to the 8th, those will cancel out the z's. Negative 36y squared z to the 9th divided by the greatest common factor that we determined was 12y squared z to the 8th is 36 over 12, or negative 36 over 12 equals negative 3. Y to the second over y to the second, those cancel out. Z to the 9th over z to the 8th is just z. So there's your greatest common factor and its factor pair, or what you would have to multiply to get the original polynomial. Alright, turn the page and let's try some more guided practice problems. In the previous focus questions, we were looking at all binomials or two-term polynomials that we're trying to find the greatest common factor for. So remember, we're going to do this in 4 steps each time. First step, find the greatest common factor of the coefficients. In this example here, we have 3 coefficients, 35, 20, and 5. The biggest number that goes into all 3 of those terms is 5. Step 2, find your greatest common variables. Well, all 3 of those terms have a t variable in it, and the smallest exponent on the t's is 2. So the greatest common factor then, so step 3 is you put those 2 together, you have 5t to the second. And our final step, you divide each one of those terms by the greatest common factor. So our final answer would be 5t to the second. Make our parentheses. If you divide each of those terms by 5 to the second, so 35 divided by 5 is 7. T to the 7th over t to the... So, do you see what I'm doing here? Let me write it down for you. So I have 35t to the 7th divided by 5t to the second. 35 divided by 5 is 7. T to the 7th over t to the second is t to the 5th. Then I go to my second term. I have 20t to the 3rd. Divide that by my greatest common factor, 5t to the second. I have 20 over 5 is positive 4. T to the first. I'm not going to write that. I could put the little 1 there, but you don't need it. And then finally, you have negative 5t to the second divided by the greatest common factor of 5t to the second. Negative 5 over positive 5 equals negative 1. T to the second over t to the second is t to the 0. It just cancels out. Try number 2 on your own. Push pause, and when you're done, push play so that you can check your work. Okay, so you're ready to check number 2. First step, find the greatest common factor of the coefficients. 12, 18, and 24 can all be divided by, well, the biggest number I can go into all 3 is 6. If you put 12, think about it. 12 can't go into 18. Then look at your greatest common variables. All 3 terms contain a k. The smallest exponent is 1. So that means our greatest common factor is 6k. Divide each term by 6k to find your factor pair. So our final answer is 6k times the quantity. So 12k to the 3rd divided by 6k is equal to 2k to the second. 18k to the second divided by 6k is equal to positive 3k to the first. You do need to put the positive sign in there, but you do not need to put the little 1 for your exponent. So we do not need to write that 1. 24k divided by the greatest common factor of 6k is equal to positive 24 divided by 6 is 4. K over k just reduces. You don't need to write anything, and then close it with your parentheses. On question number 3, I want to point out the fact that the leading term is negative. Whenever your leading term is negative, then your greatest common factor will contain a negative, or will start with a negative. So let me show you question number 3. So our greatest common factor, the coefficients of negative 32 and negative 8, they both contain a negative, or the leading coefficient is negative, so we need to use that negative. 32 and 8 can both be divided by 8. So that's step 1. Step 2, find your greatest common variables. Well, there is an R in all three terms, or both terms, sorry. There's an S in both terms, and there's a T in both terms. The smallest exponent on the R is 1. The smallest exponent on the S is 4. And the smallest exponent on the T is 1. So put those two together to create the greatest common factor of negative 8 R S to the 4th T. Negative 8 R S to the 4th T. Now divide the polynomial by the greatest common factor. Every term by the greatest common factor. So 32, I made a mistake there. 32 R to the 4th S to the 7th T divided by the greatest common factor that we just solved, S to the 4th T, is equal to, so after you divide, you write your answer in the parentheses. Negative 32 over negative 8 equals positive 4. R to the 4th over R to the 1st equals R to the 3rd. S to the 7th over S to the 4th equals S to the 3rd. You're just subtracting, remember. Then T over T cancels out. The second term is negative 8 R S to the 4th T divided by the greatest common factor, negative 8 R S 4 to the T. And notice you have the same thing on the numerator and the denominator. See, it's the same monomial over the same monomial. Whenever you divide the same number or monomial divided by the same one, it's always equal to 1. So plus 1. You would not write 0. Yes, your R's cancel out. Yes, your T's, S's cancel out, and your T's cancel out. But negative 8 divided by negative 8 equals positive 1. Alright, you do the next 3 on your own, then push play to check your work. Okay, you ready to check number 4. Step 1, find the greatest common factor of 99, 81, and negative 36. We will keep it positive, whatever our greatest common factor is, because the leading term is positive. 99, 81, and 36, I believe, can all be divided by 9. I'm going to double check to make sure there isn't a bigger number. Just a minute. Okay, I just tried to confirm that 9 was the biggest number that when I wrote all the factor pairs of 99, 81, and 36. Sometimes you have to check. I knew there was going to be many factors, so I just wanted to double check that. So 9 is still the biggest number that goes into all three. Step 2, sorry, didn't mean for it to go away, just a second. Just trying to change my pen color back. Okay. Step 2, find the greatest common factor of your variables. All three terms contain a c. The smallest exponent on that c is 1. All three terms contain a d. The smallest exponent on all three of them is 2. So to find our greatest common factor, you put those two together. 9c, I don't need to write the 1, d to the second. So our greatest common factor is 9c d to the second. If you take each one of those terms then and divide it by your greatest common factor, you'll be able to find the other factor. Okay, so I just draw my fraction bar and divide each one of those by the greatest common factor that we just solved for. 99 divided by 9 is 11. C to the fourth over just c is c to the third. D to the eighth over d to the second is d to the sixth. Plus 81 over 9 is 9. C to the third over c is c to the second. D to the sixth over d to the second is d to the fourth. Minus 36 over 9 is 4. C over c is c to the 0, so you just don't write it. And d to the second over d to the second is d to the 0, so those two cancel out. So you just leave that 4 and then close your parenthesis and you're done. Checking number 5. If you see your greatest common factor was 8, you are incorrect. Yes, 8 goes into 16 and 8, but it does not go into 44. 2 does go into all three numbers, but there is a bigger number than 2. How about 4? 4 goes into 16, it goes into 8, and it goes into 44. So I'm going to use my greatest common factor of 4. All three terms contain an e. The smallest exponent on e that I see is 4. All three terms contain an f. The smallest exponent of the f's is f to the third. There's a g in all three terms. The smallest exponent on the g is the 2. So that right there is your greatest common factor. On your test, you may only be asked to find the greatest common factor, not what the other factor pair is, or they'll ask you to factor. So the other factor pair you get by dividing all three of those terms by the greatest common factor. I'm just going to write my greatest common factor under each term. Okay, looking at the first, oh, wait a second, I almost forgot. Look at what else I forgot to do. Notice the leading term on the first one is negative, so that means our greatest common factor must have a negative. So I did forget that I need to have a negative on each one of those greatest common factors. 16 or negative 16 over negative 4 is positive 4. E to the 10 over 4 is 6. F to the 9th over F to the 3rd equals F to the 6th. G to the 8th over G to the 2nd equals G to the 6th. Do not just write minus, because notice you have a negative over a negative. So that equals a positive. 8 over 4 equals 2. E to the 7th over e to the 4th equals e to the 3rd. F to the 6th over f to the 3rd equals f to the 3rd. And g to the 5th over g to the 2nd is g to the 3rd. Sorry, I need to adjust here. See, I'm going to kind of squeeze or run out of room here. 44 over negative 4 equals negative, because it's a positive divided by a negative equals a negative. 11. E to the 4th over e to the 4th, that cancels. F to the 3rd over f to the 3rd cancels, and g to the 2nd over g to the 2nd. Hey, it looks like I just had enough room. Close my parentheses. Alright, final practice before you get a whole sheet of independent practice to do on your own. First, we need the greatest common factor of the coefficients, 36, 60, and 24. We don't need a negative because our leading coefficient is positive. So the biggest number that goes into all three, I think, might be 24. Let's check real quick. 60 divided by 24. Does that go in evenly? That does not. Alright. If you have trouble finding the greatest common factors, I do too sometimes, I admit it. So I'll go ahead and write out all the factor pairs. Let me go ahead and write them out for you. So I wrote out all the factor pairs of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9. Now I do the same thing with 60, 1 and 60, 2 and 30, 3 and 20, 4, does 4 go into 60? It does, 15 times. 5 goes into 60, 12 times. 6 goes into 60 10 times. There's a lot of factors of 60. See, in between 6 and 10, so 7 doesn't go in it. 8, I don't believe goes into it. Does not. 9 doesn't go into 60. Okay, so those are all the factor pairs of 60. Now 24. 1 and 24. 2 and 12. 3 and 8. 4 and 6. And there's no more. Okay, so the greatest common factor. I know that looks like a lot of work there, but some of you might just know this by looking at them. And it looks like it's 12. Just going to double check here. Yeah, 12 is the biggest number that's in all three sets. So down here we should have a 12. And we're ready for our variables. All three terms have an x in them. The smallest exponent of our x, though, is 2. All three terms contain a y. The smallest exponent on y is 2. And all three terms contain a z. The smallest exponent is 4. By the way, if you notice the way I write my z's with a little slash, I do that for a reason. The letter z often gets mixed up with the number 2, and I don't want to mistake my variable with my number. So you'll see some people do that. They'll make it their z and put a little slash in there to make sure they know the difference between a z and a 2. Alright, so that right there is the greatest common factor. If you needed to find your factor pair, You would divide each one of those terms by the greatest common factor. Alright, let's divide. 36 over 12 goes in 2 times. X to the 8th over x to the 2nd is x to the 6th, right? Y to the 8th over y to the 2nd equals y to the 6th again. Z to the 8th over z to the 4th is z to the 4th. You have a negative 60 over a positive 12, so that equals a negative. Had to remind myself how many times 12 went into 60 again. If I still had my factor pairs up, I could have saw that it was 5 times. X to the 4th over x to the 2nd is x to the 2nd. Y to the, y to the 2nd over y to the 2nd cancels out. Z to the 6th over z to the 4th equals z to the 2nd. And you're ready for your final term. 24 over 12 is positive 2. X squared over x squared cancels out. Y squared over y squared cancels out, and z to the 4th over z to the 4th cancels out. So just the 2 and close it up and you're done. Alright, go ahead and go on to your independent practice and do those on your own. When you're done, turn them in.